Namaskar and welcome back to this discussion on concrete engineering and technology. In this course, we have been trying to talk about fundamentals of concrete, proportioning mixes, different stages in concrete construction, special concretes, mechanisms of deterioration, reinforcement and maintenance issues. Basically, the focus is on subjects which have become important in the recent years on account of the development that has taken place in the different aspects relating to concrete engineering and technology, whether it is in the form of new materials, new methods, more challenging places of concrete application and so on. So, in the discussion today, we will look at the aspect relating to stages in concrete construction from the point of view of quality control and assurance. We should remember that quality is closely related to accidents and safety. Poor quality construction invites accidents while construction is going on or even later on. Therefore, it is important that everyone involved with the concrete construction leaves no stone unturned in ensuring quality construction. We will talk about today different aspects which are related to and are very important to ensure quality construction of concrete structures. There is a very strong element of planning for quality. Quality does not come on its own. Engineers and technical people engaged in various activities related to concrete construction, whether it is material selection, batching at a concrete plant, placing, curing, everyone has a role to play in ensuring quality. And it can be planned. If we are systematic in our approach, no matter what we are doing, we would be contributing to quality. Conversely speaking, any lacks or any lacuna or laxity at any stage leads to poor quality construction. It has an implication on the quality, and it has an implication to the extent that no matter how hard the others try, the quality is impaired. So, that is something which we would try to take a look today. The fact that concrete is mostly placed in situ adds to the problem being made more complex. Factory made products are easier to handle as far as quality control is concerned. There are different players involved in different processes as far as concrete construction is concerned, and the overall quality control cannot be allowed to drop in the no man's land. It is important that not only the people involved in the different individual aspects, material selection, proportioning, batching, transportation and so on, they do their job, but finally, the overall control of quality is also exercised and is not lost sight of. A lot of discussion today is not relevant perhaps for the precast industry, where concrete products are made, and there, because the products are made in a controlled environment, in a factory, the rules of normal mechanical engineering or a production line quality control are applicable. Today, we are concerned primarily with concrete being placed in situ in a construction project at site. Let us take an illustrative example. Consider the construction of a multi-story building, and as is the usual practice, if you have seen multi-story constructions, the shuttering for a higher level slab rests on the previous or the lower slab, and in a particular case, the slabs collapse and the accident is attributed to the fact that previously cast slab did not have sufficient strength to carry the load that came upon it during the construction of the upper slab. What we are saying is the following: if this is a multi-story framed construction, what we do is to cast the structure up to this point, and to cast the slab here, we have the shuttering for this slab resting on this lower slab. And while this slab is cast, the entire dead load of the concrete being cast, the live load of people moving around on it, the equipment that is kept there and so on, is transferred to this slab, which may not be very old. Now, it is not so difficult to believe or envisage a situation where if this slab has not gained sufficient strength, the entire portion here will simply collapse. If the dead load being applied or the construction load being applied from the slab here acts on this slab prematurely. What could be the possible causes for this situation? It could be the use of cements that had a slower initial gain in strength. It could be a faster cycle time, one floor to another, due to better equipment and mobilization, usually between one floor and the next floor. That is, the time it takes to do the columns, tie the scaffolding and shuttering for the next floor, that is what is called the cycle time. That is, from floor 1 slab to the next floor, how much time it takes. And construction people, construction engineers, they try to maintain a certain schedule, that okay, at least in a week, 3 days, 7 days, 12 days, that is how that cycle will be. That is how they plan their construction activity. Now, on account of mechanization, better mobilization and so on, it is possible to cut the cycle time. But if we are not conscious of the fact that cement takes a certain amount of time to hydrate to the extent that a certain amount of strength develops, we are really playing with fire. The importance of construction loads could have been ignored in the formal design process. When we design a concrete structure, these slabs for example, we design them for live loads, dead loads, wind loads, earthquake loads and so on. But in case the construction load happens to be substantial, then one has to formally include that in the design process itself. There could be workmanship issues such as lack of curing leading to inadequate strength development at the bottom floor. Now, there could be so many factors, and some of them can be identified through traditional QC procedures. For others, it may not work. Traditional QC procedure, as far as concrete construction is concerned, let us say deals with strength gained in cubes. Now, the strength gained in cubes is determined while the cubes are cured in water at a certain temperature. The slabs need not be cured in those conditions. They may not have been adequately vibrated and so on and so forth. The case or the illustrative example that we discussed just now briefly also brings out the fact that it is not easy sometimes to distinguish between the responsibility of a designer and a contracting agency which is involved with the construction work. Indeed, finally, it is the construction work that has collapsed, but what was responsible for it could have been a design flaw, it could have been lack of guidance to the contracting agency to carry out the work in terms of determining the kind of strength that is required for the slab before the slab above it could be cast, and so on. Now, what is quality construction? Are there any absolute standards for quality? This subject has been debated greatly in literature dealing with products, industrial engineering, management issues and so on. From our point of view, quality would mean perhaps that the concrete construction should meet the specifications, which in turn means that there should be clear specifications and appropriate test methods for evaluation. Also, consistency is another very important dimension of quality. Variability is an indicator of poor quality. specifications that we write for quality must also take into account parameters such as the importance of a structure, nature of construction and structure, and so on. The specifications that we write need to address challenges on account of use of new materials, mechanization of construction, changing professional environment. Basically, quality means compliance with standards. If the standards are such that a medium performance is expected, that is all right, in which case the product should be of a medium quality. If high performance is expected, then indeed the product should clear those higher standards. We must set the standards clearly and ensure that the construction meets that benchmark. Therefore, we must write the specifications very, very clearly, very, very unambiguously, so that it is easier to ensure compliance. From that point of view, these 3 points we will elaborate a little more. We are using lots of new materials in construction. We are using blast furnace slag, we are using silica fume, we are using fly ash, we could be using chemical admixtures which could be air entrainers, water reducers, set regulators and so on. We could be using short fibers in fiber reinforced concrete. We could be using different kinds of reinforcing bars, epoxy coated bars, fiber reinforced plastics and so on. We could be using curing or sealing compounds. We could use any of these materials in the construction process, but we must ensure that the construction product, that is the structure that we build, whether it is a building or a bridge or a dam, the quality of that is not compromised. So long as we ensure that the quality is not compromised, we can more or less use any material we want. For that, we need to have standards which will test these materials, which will test the compatibility of the use of these materials with concrete. For example, certain fibers which are not so durable in an alkaline environment would not be suitable for concrete construction, because concrete is a very alkaline medium. Therefore, designers and engineers must understand the concrete environment, the concrete properties, and then try to choose the materials they want to use to enhance properties of concrete, whether it is fresh concrete or it is hardened concrete, durability of concrete, and so on and so forth. As far as mechanization is concerned, that again needs to be taken into account when we are writing specifications, because the specifications that were valid or that can be true for small scale construction using non-mechanized methods would not be sufficient when we are dealing with using mechanical equipment in construction. Concrete is being poured into more challenging environments, more challenging very, very challenging projects are being executed with concrete, and that throws a challenge to the clients, to the end users, to be able to write a specification. One must remember also that in concrete construction, people from different companies work together. These engineers who come from different companies have different objective functions. They are not there for charity, they are for making a certain amount of profit, a certain amount of money for their company. Therefore, we cannot ensure quality at the cost, at zero cost. We can try for that, we can try for quality at low cost without allowing the cost to increase beyond a certain level. But at times an economic decision has to be made, where we say that if quality versus cost has a certain relationship, then fine, for this cost, this is the best quality that we can get, and therefore let us live with that. So, the decision to accept a certain quality is often governed by economics. and that is something which we must keep in mind. Rapid construction, the kind of example that we discussed, where a slab collapses if it is prematurely loaded with construction loads. These are examples which we need to keep in mind when we write the specifications. Let us take an example. For example, concrete is being cast underwater. Now, of course, it is important that the samples for concrete strength in such cases are also collected underwater. They cannot be collected in air. Similarly, in certain cases, the cube samples may need to be cured under conditions closer to the site than underwater. Underwater curing is standard curing. But if we are interested exactly in the strength development that is happening at site, then we need to have cubes cured under those conditions. The reason why we do not do that as a matter of standard practice is that these conditions vary widely from one place to another, from one time to another, and so on. Therefore, we say that okay, let us have a standard condition of curing: water or concrete placed or concrete cubes placed in water at a certain temperature. However, in a project specific situation, indeed there is a case that cubes are cured along with the structure that has been cast, so that we can compare or we can estimate the actual strength of the structure. Sampling for concrete from a roller compacted concrete is better with cores than with cubes. Roller compacted concrete is not vibrated using ordinary needle vibrators or internal vibrators. It makes no sense to cast the concrete in cubes using needle vibrators, where the concrete is being vibrated at site using vibratory rollers, except that we cannot create a cube using vibratory rollers. One may argue that we can create cubes using surface vibration. That perhaps is a better way of getting cubes which are more representative of the concrete cast in the roller compacted pavement or dam than a concrete cast in a cube using needle vibrators. These things, though they may sound trivial, but need to be written down in specifications or methods to be followed for quality control at a site specific document. We must remember that standards and specifications generally are guidelines. They should guide the engineer to write down and enforce the specifications at a particular site. To deviate from that is nothing wrong, except that the deviation should be conscious and with full knowledge of the consequences. If we decide to take cores from the roller compacted pavement, we should know that this is not standard concrete. This is not the concrete which has been prepared under standard conditions. This is not the concrete which has been cured under standard conditions, and therefore, the results need not be and cannot be compared with concrete prepared or cast or cured under standard conditions. Continuing with our discussion, coming to the changing professional environment. The traditional client contractor consultant relationship has undergone a major change in most major construction projects. The government or the regulator's participation in public and large projects has been redefined. With the increase in the size of projects, international participation has increased, and with that we have engineers from different backgrounds who have been educated in different standards and specifications. So, an engineer who has been trained in India would work with Indian standards, and an engineer who has been trained in England, for example, would be familiar with British standards or European standards, and so on and so forth. All these standards have different viewpoints, have different methods, and in fact, the standpoint from which they have been written is different. When private public partnership becomes a new mantra, then quality control has to be defined very differently. In a traditional situation where there is a client and the funds are being provided by the client has a lot more power to enforce certain standards. But in certain cases, when the funds are not being provided by the client, the contractor or the contracting agencies, the builders, they have a little more leeway in defining quality. There is a lot more responsibility on them in terms of ensuring quality, because at the end of it, as far as accidents are concerned, as far as the safety of the structure is concerned, it is absolutely everybody's concern. Let's take another example. Let's say that some concrete in a part of a project is found unacceptable on account of insufficient strength as determined by the cubes taken at the time of casting. It is a situation that is not uncommon. It happens sometimes that the cubes taken at the time of a casting do not meet the standards. What those standards are, we will probably talk about it a little later, but they do not meet the standards, and therefore, the concrete is deemed unacceptable. Now, what are the options open? We must remember once again that concrete construction projects are large projects involving a lot of effort in terms of time, materials, energy, money, equipment, and therefore, for various reasons, all effort needs to be made to ensure that that effort does not go wasted. It does not mean at all that we should compromise on quality. But while maintaining quality, while maintaining the standards, is there a possibility that the results that we got from the cubes are something which are in error? It should not happen that because of that error, a lot of effort gets wasted. And there are different implications of that in terms of time, in terms of reputations, in terms of the energy and the money and so on. So, what are the options that are available? As far as the Indian standards, for example, is concerned, it gives you an option in terms of non-destructive testing. It gives an option in terms of carrying out a load test for the unacceptable part. There could be an option of strengthening the unacceptable part, and of course, the option of dismantling and redoing the unacceptable part. The decision making in this kind of cases is carried out in the framework of contracting. These things have to be laid out in the specifications, that if certain things happen, then how will the situation be dealt with. Discretion at the end of it has to be given to someone. There can be a discretionary clause which says that fine, there is this issue of extra costs, whether that will be admissible or not, and if so, who will pay for it. There are implications in terms of delay in the project, because the dismantling will take time, and again we have to go back and refurbish the whole thing, create the new construction. So, there is a time delay involved. The decision thus has technical, legal, financial implications, besides involving the use of additional resources in terms of time, manpower, material, machines and so on. Engineers as professionals must be conscious of this very important role, where quality has to be looked upon within this larger framework. Quality should not be compromised, but at the same time the specifications should be clear in terms of what is really required. If that is being met, we need not be worried, but if that is not being met, then we need to take the extreme steps. One must remember that quality should not only be maintained, but also appear to be maintained. It should not look as if quality has been compromised, even though there may be a technical reason for doing so. There should be provisions which enable the engineer and the builder to actually be able to figure out a situation where there is a problem. Adequate safeguards to guard against conflict of interest, misuse of discretionary interpretation, etc., need to be built in the provisions itself. This is becoming more and more important when we are dealing with international projects, larger projects with engineers from different organizations, different backgrounds, different professional qualifications, trying to work together to the completion or the successful completion of a quality mega project. Now, let us look at the stages in a construction project. Basically, a concrete construction project, there is a concept and planning, where the project is conceived and a plan is drawn up. This is generally followed by a detailed design, including functional, architectural and structural design, followed by the construction of the project, and finally operation and maintenance. Now, if we leave out the concept and planning and maintenance, there are quality issues related to design and construction, which we must be aware of, which we need to address when we are taking a view of overall quality of a construction project. As far as design is concerned, drawings are the output that need to be checked for quality. Do drawings have quality? Of course, they have quality. The quality of construction drawings can be measured in terms of clarity of detail, the cover, the strength of concrete to be provided in the different members. Sometimes the beams, the slabs, the columns, they may have different grades of concrete to be provided. That should be specifically noted on the drawing. The detailing of reinforcement is a very, very important aspect as far as concrete construction is concerned, and that, as far as possible, should not be left to the site engineer, who has so many other things to bother about and is very likely to leave it to a barbender, who may want to go home at a particular evening and leave out some details or take a shortcut as far as placing certain amount of reinforcement is concerned, and that may have far reaching implications as far as the overall quality of that particular portion is concerned. There should be unambiguous interpretation. The drawings and the design details should provide for precautions to be taken during construction. If possible, they should actually help the construction engineer with the construction methodology. The construction engineers at site need to interact with designers to develop an appropriate construction methodology, which is in line with the design philosophy or the design process that has been followed. Coming to the construction itself or the construction phase itself, we have the concrete used and its properties or its quality, which is governed by materials, proportioning, patching, mixing and transportation. We have the formwork, which plays such an important role in determining the quality of the concrete construction. We have issues related to workmanship in terms of placing, vibration, curing and post-processing. Now, what is post-processing of concrete construction other than curing? In certain cases, for example, highway construction, there is a process called texturing, which basically means or involves creating some roughness on the surface of concrete that has been cast. Now, when should texturing be done, what is the nature of texturing to be done, and so on, is purely and simply a matter of the workmanship at site. Whereas some of these things we will talk about in greater detail in a discussion later on, let us focus for the time being on materials, proportioning, batching, mixing and transportation, which in a way comprises of the basic construction process. There are issues related to weight batching versus volume batching. Weight batching means we take the material by weight. The concrete proportion is given in terms of kgs per cubic meter, and we weigh that material and mix it. Volume batching means that we measure the aggregate and sand by volume. We use the specific gravity or the bulk density as a matter of fact, and determine a certain volume. Now, if we are using volume batching and bulk density by definition, then the amount of aggregate or sand being taken by weight could vary depending on the level of compaction and the actual geometry of the box which we use. It is not a good idea to use volume batching, but at the same time in certain cases it is impractical to insist and ensure that ready mix concrete which meets a certain standard or concrete which has been weigh batched, the contractor may not have or the builder may not have facilities to weigh batch a concrete mix. In those cases, it is not fair perhaps to insist on weigh batching, but at the same time one must not hesitate to insist on weigh batching if it needs to be done in a certain project. Similarly, washing of aggregates which need to be free from dust, oil, dirt and so on. It must be ensured that the aggregates are clean. It must be insisted, for example, that the coarse aggregate and the fine aggregate are SSD, that is surface saturated dry. If not, the correction that is required for the mixing water should be at least incorporated. Priming of construction equipment. Now, once any equipment, whether it is the batching plant or the agitator trucks or it is the slump cone and so on, whatever is used in order to take the concrete from the batching plant to the actual site of placement, the pipelines, the pumps and so on. All these equipment, when they are used for the first time, a certain amount of layer, a certain amount of concrete is deposited on the surface, and the properties of the first batch of concrete are somewhat different from the subsequent batches. Looking at another way, if the equipment has been used for a certain type of concrete and then another concrete is mixed in the same mixer, some remnants of the previous mix, whether they contain fibers, whether they contain silica fume or fly ash and so on, they will adulterate the first mix or maybe the first few mixes of the new concrete. Therefore, if we are very careful about quality, if we want to be very careful about quality, then we must prime the construction equipment with the kind of concrete that we are going to use. That is, we will have a few batches or some amount of concrete which is allowed to go waste, just to make sure that a steady state as far as the effect of properties of the mixing equipment on the properties of concrete is concerned, that part is taken out of our equation when we are talking of the quality of concrete. There are special situations, for example, for mixing manually, the use of nominal mixes. Nominal mixes is another very special kind of mix, where we say that in order to get M20 concrete or M15 kind of concrete, basically not very high strength concretes or not even medium strength concretes, we do not need to design a concrete mix, because that process is very involved, it takes more time, and in certain cases that luxury is not available with us, and we say that fine, if concrete is mixed in a particular proportion, that is a prescriptive thing. For 50 kgs of cement, so much of sand, so much of aggregate, so much of water, if it is mixed properly and placed, it may be considered equivalent to M15 or M20. That provision, if it is there, it should be used very sparingly, because that is not the way we would like large construction projects to be executed. But at the same time, for smaller construction projects, that kind of a provision needs to be there. Defining an ambient temperature range for normal construction. When concrete is being placed at site, the temperature could vary, for example, in a country like India, from anywhere between -3, -4 degrees centigrade to maybe as high as 45, 47 degrees centigrade. Now, what is the normal range in which construction activity will be allowed? In other times, we will need to bring in the special considerations which are involved for cold weather or hot weather concrete. What is the normal range where we would allow construction activities without taking those measures? When we talk of methods of transportation and the necessary precautions, these have to be spelt out in the specifications, especially if we are using something like a conveyor belt, or even if we are using agitator trucks or agitator mixers. Is there a need to ensure cooling of the surface of these trucks? When is that cooling required? What is the performance criteria that is to be used? These are things which we need to clearly write down in our specifications, and only then we can ensure compliance, which will in turn ensure quality. There could be issues, for example, for dosing part of water or a chemical admixture during transportation or just before placing. This has to be specifically studied on a case to case basis and a decision taken without adversely affecting the total quality of concrete construction. Now, coming to quantifying quality of concrete construction. At the end of it, the quality needs to be reduced to certain parameters which are measurable, and by measuring them we quantify the quality of concrete construction, and that happens for the properties of fresh concrete, the properties of hardened concrete, and also the properties of the structure which has been cast or made. Now, as far as the properties of fresh concrete are concerned, we have talked about it earlier. It could be basic tests like slump, air content, temperature at the time of placing, bleeding, setting time, whatever the engineers choose to use. There could be other specific tests or special tests for slump flow, possibility, flowability, and so on. Similarly, for the hardened concrete, the basic tests could be strength, modulus of rupture, modulus of elasticity, and so on. Other tests could be porosity, permeability, toughness. These tests help us quantitatively understand the quality of hardened concrete. As far as the structure is concerned, that is the final product. It is not the concrete, it is not the cement. So, for the test for structure, we need to make sure that there are no cracks, no honeycombing. There is a verticality in the vertical structure. The structure is not wavering. There is a certain amount of plainness or roughness, and this is governed by the type of formwork used, the quality of formwork used, and the workmanship. Issues like water tightness. If it is a water retaining structure like a water tank, Then there are performance tests which specifically test water tightness. Similarly, for structures which are supposed to be vertical, there could be a vertical wall. It should not be out of plumb by more than a certain amount. That amount needs to be clearly specified, and that is the way we ensure finally the quality of the structure. As far as a ready mix concrete plant is concerned, there are tests for individual materials. It is important to have specified sampling procedures with the frequency. This frequency of tests can be based on time, that is, the sampling will be done every day, every week, every 3 days, twice a day, and so on. It could be specified in terms of the volume of concrete being mixed, because a batching plant need not produce the same amount of concrete every day. There can be a scheme of thought which says that, well, for every cubic meter, every 10 cubic meters, every 50 cubic meters, the material being used will be tested. The rationale could be that after a certain amount of time, the batches of the material being used could change, the time that has elapsed might be different, and so on. We must remember that some of these items need to be spelt out simply to clearly define the rules of the game, and it is important from a professional and a legal point of view. These provisions have legal implications, there are financial implications, and therefore, unless they are written down in that form, it is difficult to ensure compliance. As far as the testing of concrete itself is concerned, it could be the same tests, slump, air, temperature, setting time, and so on, but the important point is where should these tests be carried out as far as quality control procedures are concerned. They can be carried out at the plant, they can be carried out at the site of placing, or both these places. Finally, concrete is going to be placed at a certain location, and that is where the concrete must satisfy certain criteria. But it stands to reason to believe that there is no point in taking a concrete which is unacceptable to begin with all the way to the site of placement and then reject it. Therefore, there needs to be tests at the plant itself. These tests at plant and at site should account for differences that might occur during transportation, for example, slump loss, air loss, evaporation of water, and so on. These are the kind of considerations which would give rise to a procedure by which some water or a chemical admixture may be added at site and not at the batching plant. This is especially true, for example, for an accelerator. There is no way an accelerator can be used in a concrete at the batching plant, and the concrete has to be transported. So, there is a case where someone will say that, well, let me use everything else in the concrete at the plant, have certain properties, take the concrete to the site of placing, add the accelerator, and then do the casting. In this case, obviously, we need to have quality control parameters, the acceptability of concrete in terms of the concrete at the plant and at the and for the concrete at the site. There is this issue of frequency of sampling. Again, the frequency could be based on time, twice a day, once in 3 days, or it could be based on the volume of pour. Since testing involves use of resources, if it is not specified, it may not be carried out, and therefore, it must be specified. Here too, the issue of frequency of testing is very important. How often should the sampling be done for properties of fresh concrete, properties of hardened concrete, whether it is at site or it is at plant, whether it should be governed by time, that is twice a day, once in 3 days, once a week, whatever, or should it be on the volume of the pour for every 10 cubic meters, every 50 cubic meters, every day regardless of the volume, and so on. This needs to be laid down. It needs to be laid down because testing involves consumption of resources, and somebody may like to cut corners if a minimum of sampling frequency or a minimum amount of sampling is not specified. Now, having discussed the different aspects relating to quality, now let us try to conclude the discussion for today with some homework, as we usually do. We could study the quality control parameters for concrete construction in different specifications. We have been talking about today of different specifications being written for different kinds of concrete construction in different countries. The specifications could be different for dams, they could be different for bridges, they could be different for pre-stressed concrete, they could be different from India to the United States or Singapore or Japan. We could study the quality control parameters in these different conditions and different countries. It would be interesting also to study the differences from the point of view of quality control in structural steel and concrete construction. Structural steel construction is not something which we have at all talked about in this course, nor do we intend to. But the principle is that steel is a factory made product, roll sections are made in factories, built up sections are made at site, fabricated at site, and the whole range of issues as far as quality control is concerned is quite different. The fabrication drawings for steel structures are often made at site, not so the detailing of reinforcement. Seldom is detailing of reinforcement formally done and recorded at site. The same is true with the design of formwork. That is something which we will probably talk about briefly in some other context. Enabling structures, temporary structures, these are all very different as far as steel structures is concerned and concrete is concerned. So, from the point of view of quality control, it would be an interesting study to understand these things a little bit better. We could find out more about the roles and responsibilities of the contractor, the consultant and the owner from the point of view of quality control. At the end of it, the quality of the product, the structure is of importance, is something sacrosanct to everyone. But how everyone approaches these problems, how the different agencies involved approach their problem, there could be very interesting differences, and that is something which we could study a little bit more. Thank you.